Ever tried pushing a gate along the side of its hinges or near the side of its hinges? Now, asking of what is hinges. Hinges are the connectors that connects a gate or anything with a wall. Alright, just imagine the blackboard. My blackboard is a gate. Yes, one part of the gate. And one side of the gate is connected with a hinge to a wall. Now, what the question was, have you ever tried pushing the gate from this part of the gate? If you have done so, have you ever wondered why it is difficult to open the gate? No matter what, even though you give a maximum amount of force, it is very difficult to open. If you haven't, please do try this and let me know how you felt the experience of it. Alright. Hello viewers and my dear students. I'm Mithunas Nair representing St. Anthony's ICC School. Well, if you are enjoying our videos, please do like, share and subscribe to our channel so that we will be able to keep you in touch with the topics of various content regarding the ICC syllabus. Alright, getting back to the example that I gave you at the beginning of the video comes on the application of moment of force. Well, if you have guessed it, that's right, we are going to study about moment of force in this video. Okay, now imagine a body pivoted at a point O. For example, there's a body, it's an irregular body, it doesn't matter. Now it's pivoted at some point O. Now what I do is, I'll draw a horizontal line passing towards the center O. Alright, that's the horizontal line. Next, now imagine that I provide a force along the horizontal line, that is through this point. Alright, what do you think? Do you think the body moves or do you think the body remains in the same position? Same position. Well, if your answer is the body remains in the same position, it's very correct because it is pivoted at a point O. Now imagine that the body is free and not pivoted. What do you think happens? Obviously, the body starts moving at this direction. Yes, but here this doesn't work because it is pivoted at point O and we are giving a force that acts exactly horizontal to the horizontal line. Now consider that I'll just erase a point of force. What happens if I put a force or if I allow a force act on the body towards the vertical direction? Towards a vertical direction. Do you think the body moves? Exactly, the body moves, but in a circular motion. But in a circular way. Why do you think that? Because the body is pivoted. Obviously, when it is pivoted, if you give a force at a particular angle, it starts rotating. So, this force that acts on the body is called as moment of force. Now, when I join this point along with this point, along the line, I'll just join the points of force. What I get is a 90 degree, right? So the force will be maximum or the moment of force will be maximum when the angle is exactly 90 degree. Of course, if you ask me whether if it is less than or more than 90 degree, will there be a force acting on it? It will. But the moment of force will be less. To get a maximum moment of force, you have to apply the force exactly 90 degree on the body. If you give the force at an angle of 0 or at an angle of 180 degree, the force acting on the body will never give you any moment of force. So the distance from O to this point, I call it as P, is the perpendicular distance at which the force is acting on the body. And there are two conditions for a body to possess moment of force. And those two conditions are, first one, the magnitude of force applied, or you can simply write it as force applied on the body, and the second one is the perpendicular distance at which a force acts on the body. Second one, perpendicular, this is the symbol for perpendicular, distance at which a force acts on the body. By combining these two, we'll get the formula for moment of force. It's very simple. Moment of force is equal to force applied, that is F, into perpendicular distance. I'll just write it as perpendicular D. Alright. So this gives you the formula for moment of force. Now what is the SI unit of moment of force? Very simple. What is the unit of force? Newton. What is the unit of distance? Meter. And therefore the SI unit of moment of force is Newton meter. And when you talk about moment of force, there are two kinds of moments that are produced on a body. One is anti-clockwise moment and the other one is clockwise moment. So when the body is rotated at anti-clockwise direction is called as anti-clockwise moment, and when the body is rotated at a clockwise direction is called as clockwise moment. So these are the two types of moments that we can see in our daily life. So from all these examples, what do we conclude? We can conclude that by applying a less amount of force at a particular or at a large distance, the amount of work could be done very easily. That is, the larger the perpendicular distance, the less force is required to turn a body. This is what moment of force concludes. Next, going to the concept couple. A couple, what is a couple? Two equal and opposite parallel forces not acting on a same line is called as couple. For example, when you try to open a door, there are two forces acting on the door. One, the force you apply on the handle of the door, and the other one, the force that is exerted at the hinges of the door. Alright? The force exerted on the hinges will be opposite to the force that acts on the handle of the door. So this is what couple means. Now we'll just try solving a few numericals that comes under the concept of force and moment of force. Alright, so I'll be doing very few. The rest will be up to you because you have to try doing yourself so that you will understand how to perform the numericals. And if you have any doubts regarding the numericals, you can just ask so that I'll be able to teach you. First one, you can look into the numerical. The moment of force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. So given the force acting on a body is 10 Newton. So the first is force acting on the body is 10 Newton and the moment of force given is 5 Newton meter. So moment of force is given as 5 Newton meter. Now what are we supposed to find? We are supposed to find what is the distance or what is the perpendicular distance to which the force is applied on the body. That is distance, we don't know, and the SI unit is meter. Alright, why meter? Because this is given in meter. As you can see in the question, this is given in meter, therefore this also will be in meter. If it is given Newton centimeter, you will get it in centimeter, and usually it won't come like that. I'm just giving you an example. Alright, we are supposed to find the perpendicular distance, which I just written as d. Alright, so F force is given, moment of force is given, we have to find the distance. You already know the formula. Moment of force is equal to force into perpendicular distance, which we can write it as d. Now what is the moment of force given? Moment of force is 5 and the force given is 10 into d. Alright, I'll transfer the 10 to the other side so that I get 5 by 10, which is equal to d. So the answer is very simple. The answer is 0.5 meter is equal to d. That's it. Now let's take a look into a different question. A nut is opened by a wrench of length 10 cm. If the least force required is 5 Newton, find the moment of force needed to turn the nut. So it is given that a wrench is 10 cm long. That is the distance of the wrench. Alright. And the next one given is force is around 5 Newton. Force is around 5 Newton. What we are supposed to find? We are supposed to find the moment of force, and moment of force Newton meter, right? The SI unit. Now what we have to look is, this is given in meter, this is in centimeter. So either I have to convert this answer into centimeter or this into meter. What I am going to do is, I'll just convert 10 centimeter into meter. It's very simple. 10 centimeter to meter is 0.1 meter. Right? Alright, let's solve it. Now moment of force is equal to F into T. That is equal to 0.1. That is equal to 5 into 0.1, which we get 0.5 Newton meter. Hope you understood that. Now, those who have any confusion with solving 5 into 0.1, I'll just tell you how it is. 5 into 0.1, you can go for your basic mathematics skill, that is 0.1 into 5. 5 ones, 5, 5 zeros, 0. And since after 0.1 number, before one number, you have to put a point. Therefore, you get 0.5 as your answer. And that's how you get 0.5 Newton meter. And I guess most of the problems are regarding moment of force in this chapter. I've done 2 sums regarding your textbook. So the other you try to do that, else I'll just solve it in the next video. So don't hope that I'll be solving everything. I'll just select the difficult ones, and in that at least 2 will be given to you. The rest will be solved by me. Alright? That's it. End of today's class. Take care and be safe. Thank you.